Hello everyone, this is Jala Babu. My roll number is 25VQ5A0408 from ECE department in VVT College. Today I will talk about program read-only memory, program logic array, and program array logic. The shortcut forms is the PROM, PLA, PAL. And introduction to programmable logic devices. Understanding PROM architecture and functionality. What is PROM? Programmable read-only memory. PROM is a program read-only memory. Is a type of digital memory that can be programmed once that after manufacturing. Unlike standard ROM, PROM chips are blank and can be customized by the user through a special programming device. Core architecture. Fixed and array are for addressing decoding, programmable or array for data output, fusible links that can be circuited below, non-volatile storage retaining data without power. This is the block diagram of PROM has fixed and array and program or array. PROM programming process and applications. Initial state number one is initial state, two is programming, three is verification, four is implementation. Initial state PROM arrives with all feasible links intact, representing all ones in the memory array. The program is meaning a PROM programmer applies high voltage pulses to selectively blow specific fuses, creating the desired data pattern. Fourth one is verification. The program PROM is a read back to verify correct data storage before deployment. Implementation. The permanently programmed PROM is installed in the target system for reliable operations. Key applications. Microcontroller program storage, lookup stable for mathematical functions, character generator for displays. Boot firmware in embedded systems, digital signal processing algorithms, configuration data for hardware systems. Program logic array. Second is program logic array. PLA. This shortcut forms PLA. Structure and working principle. Understanding PLA architecture. A program logic array PLA is a spotted program logic device feature both program and or arrays. Thus, dual programmability provides maximum flexibility in implementing complex Boolean functions. Programmable and array generate product terms from input variables and their complements. Programmable or array combines selected product terms to produce sum of product outputs. Logic output. Optional output register can timing and stability. The flexibility of a PLA makes it ideal for implementing multiple Boolean functions simultaneously with shared product terms, optimizing cheaper consumptions. PLA truth table implementation and Boolean function realization from truth table to PLA. Implementing Boolean functions in a PLA involves converting truth table into minimized sum of product expressions. Each product from in the end array can be shared across multiple output functions. Implementation steps. Create K-map from the truth table, minimize Boolean expressions, identify common product terms, program and or arrays, verify output functionality. Example function, consider implementing F1 equal to AB plus A dash CF2 equal to AB plus BCF3 equal to A dash C plus BC. The PLA efficiently implements all three functions by sharing the terms AB, AC, A dash C, and BC across the R array, demonstrating the power of programmable logic. Programmable array logic. The shortcut forms PAL, design and configuration. This is the top end of program and configurable terms forming input logic. This middle one is fixed or array. This is the combines product terms into sum of outputs. Last one is output logic. Final outputs with optional register paths. PLA device characteristics. Programmable array logic PLA device feature. Programmable and array combined with a fixed or array. This architecture offers faster operations and similar programming common device popular for high speed amplifications. Simplified programming. Only the end array requires programming reduce complexity and programming this significantly. Faster propagation. Fixed or array elements eliminates on level of programmable delay, improving overall circuit speed. Cost effect. A similar circuit reduce manufacturing maintain excellent performance. This is the PLA versus PAL compass analysis. This is the starting black and green color is the programmability. The next one is speed. The third one is cost efficiency. For the easy circuit diagrams, internal architectures, comparing internal structures, PROM architecture, fixed and fixed and array for addressing decoding with programmable or array for data outputs. PLA configuration. Both end and or arrays are fully programmable for maximum design flexibility. PAL layout. Programmable and array with fixed or array for simplified faster operations. Each architecture represents different trade-offs between flexibility, speed, and complexity. Understanding these internal structures helps designers select the appropriate devices for specific applications. Real-world applications in Indian electronics industries. Industry implementation across India. These the types of implementations. The first one, ISRO space programs. ISRO space programs means is the PROM and PAL devices is used extensively in satellite control systems and launch vehicle electronics for reliable and radiations ordinary operations. Next one is telecommunications. Programmable logic devices manage switching networks and signal processing in India's expanding 5G infrastructure deployment. Next one is defense electronics. DRDO utilize the programmable logic device in radar systems, missile guidance, and secure communication equipment. Next one is manufacturing automation. PLA devices control industrial automation systems in automotive and textile industries across Gujarat, Tamil Nadu, and Maharashtra. Railway signaling. In Indian Railway employs PAL devices in modern signaling systems and train control machines for enhance safety and reliability. Growing make in India, electronics sector is these application LED controls and IoT device manufacturing. Summary and key takeaway. Choosing the right programmable logic device. PROM, best for permanent data storage, lookup tables, and fireware. Features one-time programmable non-violent memory. PLA best for complex multi output Boolean functions with term sharing. Features maximum flexibility with dual programmability. PAL best for high speed applications requiring quick implementation. Key features for faster operations with simplified programming. Framework. Consider PROM when you need to permanent one-time storage data will not to change after deployment, uh, and the cost is a primary concern. Consider PLA when multiple complex functions needed. From sharing in beneficial, maximum logic density required. Consider PAL when speeds are is critical for appliances, similar programmability, cost performance best. The future of digital design. While modern FPGAs have largely replaced these devices in many applications, understanding PROM, PAL fundamental to comprehending programmable logic evaluation and selecting appropriate solutions for specific design constraints. Thank you.